So today, we're gonna present to you guys about our experiment on frictional forces. So, hello everyone. My name is Nur Aisha Sofia binti Azmi. You can call me Shah.
Hi, my name is Siti Nur Ainul Aina binti Mat Ilyas.
Hi, my name is Nur Natasha Khairina binti Ahmad Syafi'i at Lais Muhammad Saufi.
So the first thing is our objective of the experiment. The objective of the experiment is to determine the coefficient of static friction of different surfaces. Next, the apparatus that is needed to conduct this experiment is wooden block, rubber band, 50 grams of masses, 10 Newton spring scale, string, and tabletop. As you can see from the slide above, that is how we conduct the experiment.
For the procedure of the frictional force experiment, first procedure is the mass of the wooden box has been measured and recorded as M. Second, the apparatus of been set up as shown in figure 5.2. The tabletop was made sure stable and horizontal to the ground. The spring scale of the wooden box have been attached with the string and placed horizontally on the tabletop. The rubber side of the block has been ensured to be face downward. 5. M equals to 50 gram mass was placed on the wooden block. The spring was pulled slowly. Once the block started to move, the spring scale reading was recorded. The value as F and tabulated was recorded in table 5.1. Step 4 until 5 was repeated for 3 trials. Another 50 gram mass was added on the wooden block, and step 5 to 6 was repeated. The step was repeated until total of the M is equals to 500 gram is on a wooden block. And last but not least, step 1 until 8 was repeated. This time, the rubber side of the block was made sure facing upward, and the data in table 5.2 was tabulated. For the result, we are going to have two different kind of result, which is the first one is rubber surface toward the floor, and the second one is non-rubber surface toward the floor. So in this result, we are going to repeat, which is 3 trials to get the average.
Here are the analysis that we do for our lab report. The first one is we have to draw and label the free body diagram of the wooden block as stated in the slide. Second one, we have to plot a graph of static friction force against normal force for the rubber surface and non-rubber surface. The third one, we have to use the gradients obtained from the graph to calculate the coefficient of static friction for each surface. The fourth one is we have to compare and discuss the coefficient of static friction obtained. For the fourth one, the answer is coefficient of static friction of rubber surface wooden block toward the floor is greater than static friction of non-rubber surface of wooden block toward the floor with difference 1.22. The differences occur due to rubber surface of wooden block produce higher frictional force than non-rubber surface of wooden block. This is the graph for rubber surface of wooden block. And this is the graph for non-rubber surface of wooden block.
So, the first question is, how can anti-lock brakes stop a car in a shorter distance than regular brakes? So this is the answer. When anti-lock brakes are applied, the braking system works to keep the wheels from locking up or skidding, keeping them in contact with the road. By regulating the frictional force between the tires and the road, this is accomplished. Applying regular brakes in an emergency situation increases the probability of the wheels locking up because the frictional force is being overloaded. This frequently results in a loss of traction, causing the wheels to skid on the surface of the road. The car's total deceleration and stopping distance are increased when the kinetic friction produced by the skidding wheels is smaller than the static friction.
For question number 2, it says from your experiment which material has the highest coefficient of static friction. Does this agree with your hypothesis? Do you think this determines the coefficient of static friction? So to answer these questions, we know that rubber is known to have greater flexibility and resilience than many other materials. This improved grip of the rubber surface, increasing contact and traction between the rubber and adjacent surface. So if we take a look at our hypothesis, it says the coefficient of static friction between rubber surface to the floor will be greater than the between non-rubber surface and to the floor. Since the rubber surface have higher frictional characteristic due to their elastic and higher friction nature, we can expect that the rubber surface in the contact with the floor will have a higher coefficient of static friction. This means that when pressed against the floor, rubber surface generate more resistance to the motion than non-rubber surface.
Question 3 is, once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. So, it has already established that the coefficient of static friction between rubber surface and the floor is expected to be greater than the coefficient of static friction between non-rubber surface and the floor. However, you are now interested in the motion that occurs once the mass begins to slide. It is important to note that frictional forces affect the movement of an object based on the expected differences in coefficient of friction. Here are several possible motion scenarios after an initial force is applied and the mass begins to slide. Smooth motion. The mass may move smoothly if the kinetic friction between the rubber surface and the floor is less than the applied force. In this case, the object moves consistently and continuously with no significant stopping or hesitation. It moves at a relatively constant velocity until it is affected by external force factors such as air resistance or an uneven terrain. Move to the next point. Stop and go motion. If the kinetic friction approaches or exceeds the applied force, the movement may exhibit stop and go characteristic.
The discussion that we can conclude from our experiment is friction is the force that resists motion when the surface of one object comes in contact with the surface of another. Friction is one of the most significant phenomena in the physical world. Next, Friction or frictional force is defined as the force that resists an object's motion on a surface. The object can either be stationary or in motion relative to the surface. Friction occurs where the object is in contact with the surface. In other words, it takes place between two surfaces and hence is a contact force.
Surfaces are not perfectly smooth. They consist of bumps and irregularities when two surfaces come into contact. These bumps adhere and interlock, making it difficult for the surface to move. Because of this resistance toward motion, friction is considered as a force. The frictional force is non-conservative when an object moves from one position to another against friction. Energy is not conserved as some of it is lost through heat. Frictional force is the force generated by two surfaces that contact and slide against each other.
These forces are mainly affected by the surface texture and the amount of forces impelling them together. The angle and position of the object affect the amount of frictional force. If an object is placed at the flat against an object, then the frictional force will be equal to the object's weight. If an object is pushed against the surface, then the frictional force will be increased and becomes more than the weight of the object. Friction is the force that opposes motion between any surface that are in contact. There are four types of friction, which is static, sliding, rolling, and fluid friction. Static, sliding, and rolling friction occurs between solid surface, while fluid friction occurs in fluid and liquids and gases. So, for the conclusion, the coefficient of static friction of different surfaces were determined from this experiment, and this is some references that we use for making this lab report video. That's all from us. Thank you.